The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Larry. Our next presenter is Larry Kahn, who is a retired professor from Georgia Tech. Larry, is that the story we're going with? And he's also the current chair of ACI TAC, among other duties. So Larry's going to specifically be talking to us about academic instruction and how it can improve codes and standards. Larry, wait.
Good. You can ask questions at any time. You saw questions up here. We as a group are going to answer a bunch of questions and have discussion after all of us speak. So this talk is all about academic instructions. We're talking about codes for performance, and particularly the 562 repair code. And what's important here is you heard these guys talking about, contractors need experience, engineers need experience, engineers need to know words like repair or assessment and so forth. Well, where does that come about? Well, what I've discovered is it's nice to know if the students coming out of a university actually have such great knowledge of jargon like a repair or epoxy or some things regarding that structures need not just new design, but rather need some maintenance, may need assessment, may need repair and rehabilitation in order to have a long and successful life. So that's my goal here, is to talk some about what goes on. Well, my perspective. Well, first of all, is as a teacher. I am a professor emeritus. As a teacher, to develop assessment, repair, rehabilitation in some kind of sequence, along with my fellow faculty members, Abdul Zirk and David Scott at Georgia Tech. And this began in the early 1980s, where we started setting up a sequence of rehabilitation courses. And then as a researcher, I started beginning my studies of repair rehabilitation, particularly regarding seismic retrofit, but then leading into just all kind of rehabilitation of structures in the 1970s. Why did I do that, right? How does a young academic who got all kind of instructions on seismic resistance from Meta Sozen and from Bob Hansen and all, right, to design new structures? Well, in all my reading, all the difficulty with structures were existing structures falling down. That is a major cause of death in earthquakes, even today, is existing structures. Structures built in the 1970s and before, which occupy most of our built environment, they're the ones that are vulnerable. The ones that are vulnerable to use and need to be torn down and rebuilt are those existing structures that have not been maintained and for which people don't know how to repair them. So repair and retrofit is a huge industry and has a lot of creative problems. So that means students could well be interested. And as a past chair of 562 and writing the code, and really now as a current TAC chair, I see what's happening throughout the ACI and our technical community. And at least a third of all committees within ACI have something dealing with rehabilitation and existing structures. That is, they don't call themselves repair or rehabilitation like two of our committees do, but the cracking committee, very concerned about cracking of new construction when you first place concrete, but also has documents on repair. Non-destructive evaluation has a lot to do, not only with evaluating how a new structure has been built, but evaluating existing structures. So you can go on committee and committee and committee, which you belong to. Some of it is dealing with existing facilities for repair industry. And repair is about a third of all that we all are doing. So education needed. Well, as said before, we have a large segment of the construction industry, generally over about $20 billion annually is spent on repair construction. This is a big market area, which our students and our young engineers are going to participate in. There's poor repair performance, and again to repeat, after 10 years, only 30% of the repairs are satisfactory. That's horrible. We would never accept that as part of a new construction. It's an exciting area requiring maximum creativity and occupies both office work and field work. Young engineers love to get out in the field and see things and see how work is done. And it requires real creativity. What Tarek talked about in how to solve new problems, you can't go to a 318 code and says, here's how to build it new, because it's there. You have to deal with real special problems which take a lot of creative thought. It provides great opportunity for my young graduates, or if you're in academics, your young graduates. And more consulting firms require engineers to do assessment and repair. It used to be that there was only a few forensics firms that just did, forensic analysis, such as WJE, Rathrath and Johnson, SGH, or, structures. But now, more and more firms have a division within them that does forensic analysis. And engineers that are doing 70% of new design are also called upon to go out and do assessment, evaluation, reconstruction, and rehabilitation. So throughout ACI and throughout your careers, repair and rehabilitation is becoming more and more an aspect of what you do. And as you hire young engineers, you would at least like them to know the basics of what happens in repair and rehabilitation. So what I did starting about a year ago, and for a long period of time, is I queried the faculty network. If you're a faculty member and not part of the faculty network, get on the ACI webpage and become part of the faculty network. It's great. It's a great way to have what's going on in the academic community. So I queried, there's over 200 people in our faculty network, and I got back 29 responses, people from 26 universities, 21 of them, including Puerto Rico, are local to us, 3 from Canada, and then Australia, Italy, and Sweden as well. So it's not a lot of schools out of about 200 universities having departments of civil engineering. We got 26 basically responses, or that's 200 here in the US, so you take away 5 from that, it's a fairly small number that actually got a response. But in Milan, we look at this table. I have on the left here the number of courses in a school, and then the next one, the number of schools with those, and then I list some of these universities. 4 courses, this is generally at a senior level or elementary graduate level. 4 courses from Politecnico de Milan. These are fantastic courses. I've looked at some of those. So in Italy, there's a lot of historic structures dating back for a couple of thousand years. Most of those need some kind of retrofit maintenance that has to be very carefully done. They give special degrees in that, particularly historic retrofit. So that's a special case. They are wonderful. A couple of schools give 3, us at Georgia Tech and the University of Illinois at Champaign-Urbana. I went to Illinois at Champaign-Urbana. Maybe that's where I got some ideas. And then 2 courses in 3 universities, Pitt, Purdue Northwest. That's not the real Purdue. That's Purdue Northwest and University of Toronto. But then several schools, 15 of them, give at least 1 course in rehabilitation. Going from University of Arkansas down to University of Victoria. I'll stand on my feet, right? So many different schools have at least a course, and then a couple of other schools have at least part of a course in which rehabilitation is discussed, and this is primarily in the materials area. They're given an advanced course in cementitious materials, and part of that course will be dealing with repair materials. Some of it, in many deals with FRP reinforcement as a construction material. So there's some integrated, at least so students get an idea that there's such a thing as repair, that structural concrete structures need maintenance are going to need some rehabilitation. But not many schools, but a lot of work, significant work is going on. And what kind of things are these students learning? Well, this is a huge table that I prepared dealing with the overall look at the top, assessment, rehabilitation, dealing with the entire structural system, and then repair, design, and construction. Not going to look at all those, but look at the blue ones are the topics that occurred in syllabi given to me by all those different schools. So the number one thing over an assessment, a condition assessment needing documentation, field investigation reports, right? So overall, you're looking at an existing structure, and then what do you look at in terms of rehabilitation, decision criteria for evaluation, repair, and rehabilitation. This is great using the documents from 364, the committee called rehabilitation, right? So, and that is investigation prior to rehabilitation construction. So a lot of them have to do with that. If I just look under that a little bit, many faculty are teaching forensics, learning through failures. And there's some ASE books on that and a lot of great articles. Students get really excited about looking at buildings falling down and then learning about why they fell down, right? And you can laugh at it, whether it's the engineer or constructor or a tornado. So it really excites the students. And then repair, design, and construction. Generally, there's some kind of summary on repair construction techniques. Chain dragging in order to listen, some rebound hammering on it to listen to what's going on. And then as well as FRP, design and construction, a lot of faculty seem to have something to do with FRP and like to get their students interested in some external FRP repair. So that can cover up a pretty nice undergraduate course, and the students get a pretty good investigation. One thing we've done that's probably the most exciting thing for the students is the course where we actually bring them into the laboratory and a lot of non-destructive evaluation. And they build some concrete samples, and then we test them using all kind of non-destructive evaluation techniques, many on loan from companies that make this NDT equipment. And the reason they loan them to us is they hope the students go to work and then buy the stuff, right? And they do. So we'll make things like panels. There's a little panel sitting up there, and they put in inclusions. So some of these say there's some sand, we put in Coke bottles, there's a particular delamination, we put some plastic down, so we make the lamination as pretending the thing is really old, different size reinforcing bars, so that when they use picometers, they can pick up you can pick up if there are different size bars and the like. The stuff cures, and then we use all these different techniques on them. Of course, they think that, let's say the Coke bottle is going to be in the upper left, and all of a sudden I turn the sample a little bit different way, and so they can't find the Coke bottle, and what's wrong? Because I turned the sample around and screwed them up. But, we use, infrared thermography, and then like this delaminated part that's here at the bottom actually turned out to be at the top. And they start clearly seeing what different kind of techniques can do, but more important, like when using ground penetrating radar, they see how difficult it is for a novice to see what's going on. So they gain a real appreciation for either having to learn it or technicians that are actually doing these kind of investigations and what different techniques are good for what different items. And then we take a couple of cores out of them, and then they evaluate that it's not just easy to take a core and get good sampling and how different the concrete is in different parts. So this really excites the students. They love it. They learn a lot. So if anybody gets into doing these courses, I really recommend doing some laboratory work and non-destructive testing. So what do they use? And what kind of books can you use if you're starting a course or if you're trying to learn about it? Most all of these are ACI publications. Concrete Repair Manual is used by almost everyone. That's generally a 3-volume set that you can get download from ACI. I put up here the 4th edition, which is the current one. I really recommend the 3rd edition. It has many more international publications, which, you know, have since decided they don't want us to release those, but they're great. You can get that from us or ICRI. Many people use Peter Emmons' book, but that costs money. All the rest of these, not the 562 code, but the guide to assessment, 440 documents, 546 repair code documents, and others, you can get by having your students become student members of ACI, and then they get to download a bunch of documents, so they get basically all the textbooks for free. They read them all, they become ACI members, and then they come onto our repair committee. So it's, you know, really great. But having students take at least part of a course, and generally one course, get their hands dirty, learn about repairs, really prepares them to enter the industry and not make the mistakes that became obvious from Tariq's presentation. All right, we'll ask questions and talk about it with questions when we're all together after. Thanks.